Today we're going to continue with our compound inequalities. We're going to work on absolute value inequalities. We're going to learn a little bit about what this means. We're going to relate them back to our absolute value equations. So in an inequality that contains an absolute value expression, okay, it's called an absolute value inequality. An example is the absolute value of x is less than 2 and the absolute value of x is greater than 2. We'll recall that when we talk about the equation, the absolute value of x being equal to 2, it means that the distance between x and 0 is 2. By definition, the absolute value is the distance from 0. So in the inequality, when you have the absolute value of x less than 2, it means that the distance between x and 0 is less than 2. Means that the value of x is between negative 2 and 2 to make up that distance. This is an and inequality. An and compound inequality, okay? So we can start by writing the lowest number, negative 2, which is less than x, which is less than 2, and you can see the graph of that. So it's between, right, those two values. When we have an inequality that is the absolute value of x greater than 2, it means that the distance between x and 0 is greater than 2. So if the distance from 0 is greater than 2, it means all of the values beyond negative 2, all the values beyond 2. This becomes an or compound inequality. So these relate to and have everything to do with the symbol. The absolute value inequalities that are less than are and inequalities. The ones that are written as greater than are or inequalities. So let's kind of take a look at the core concept. Before we do that, we're going to kind of relate this back to the equation. So knowing that when you had an absolute value equation, the absolute value of x minus 4 being equal to 6, we remember what this means. It means that this expression, x minus 4, is equal to 6, or we know that this expression, x minus 4, is equal to negative 6. So it's the distance from 0 has to be 6 units on either side of 0. So the expression itself is either equal to a positive 6 or a negative 6 inside the symbol. So let's relate it then to the absolute value inequality. If we have this less than or equal to 6, this question is asking when the inside expression, the one inside the symbols, is between negative 6 and 6. Or when is, okay, so this is an and inequality. All right, let's do that. And it would look like this. It would look like the negative 6 is less than or equal to this x minus 4 expression, which is less than or equal to a positive 6. Okay? What if we had this compound inequality, absolute value of x minus 4 greater than or equal to 6? And this question is asking for when the expression inside the symbols is greater than or equal to 6 or less than or equal to negative 6. So this is an or compound inequality. And this looks like this. We have our expression x minus 4 is greater than or equal to 6, or x minus 4 is less than or equal to negative 6. Now look what happened. Look at this symbol reversal, okay? All right? So think about what this means, because remember, inside the inequality right here, this value is either positive, which we see here, or if it's negative inside there, we'd have to multiply both sides of this inequality by a -1 in order to see this -6, and we know that we multiply or divide by a negative number, it flips the sign. So this is the compound inequality that we're talking about, and that makes it beyond or below, beyond 6 and beyond -6. So here's that core concept. And again, just kind of, highlighting and letting you know that these less than inequalities are and inequalities. The greater than are the or inequalities. Here's another important thing to keep in mind. C must be greater than 0, right? By definition, the absolute value of something is its distance from 0, and distance is measured in positive values. So we'll see what happens when, how we treat each one of them when we solve them. So let's solve some. So the first one, the absolute value of x is less than or equal to 3.5. So we're wanting to know, so we have a negative 3.5 is going to be less than or equal to x, which is less than or equal to a positive 3.5. Okay? It's kind of the basic definition. It's a and compound inequality that could be written like this and graphed like this. So when you have a less than or equal to, you want to have a closed circle and try to do as best I can. If you want to label it on your graph as negative 3.5 and 3.5, all the better. But if you can make it look like it's halfway between the -3 and the -4, then that'll be good enough. So this is an and inequality, and it shows the numbers that are between. Switching to the middle one, the absolute value of k minus 3 is less than -1. By definition, we know that the absolute value will never be -1, okay? Because the definition of absolute value of an expression must be greater than or equal to 0. So it cannot be less than 0. So we say that there is no solution for this type of inequality. Now, pay attention, that's when the symbol is less than, okay? Because we'll use the words here. By definition, the absolute value must be greater than or equal to 0, and therefore we can't graph it because there's no solution. But let's look at what's happening in part 3. So this is an and inequality. And so we'll be solving two different equations to find what two numbers x is between. So we'll have 2w minus 1 is less than 11. And we'll also have 2w minus 1 greater than -11. Remember, we talked about that when the expression inside is negative, in order to have this expression right here as positive, we're going to multiply both sides by a -1. So let's see what that looks like. So when the expression is negative, we start out with our original expression. We know that we can multiply this side of the inequality by -1 and multiply this side by -1 to get rid of the negative sign, to get the expression 2w minus 1, but we have to flip the symbol. So that's how we get the second inequality that we're going to be solving. So we'll be adding 1 to both sides to solve. So we can write 2w is going to be less than 12. And we also have 2w is greater than a negative 10. Now we're dividing by a positive. So W will be less than 6, and W will be greater than a negative 5. So the compound inequality, I'll start it over here, negative 5 is less than W, which is less than 6, and then we can graph it. So an open circle at negative 5, open circle at 6, and all the numbers between. Okay, that's what the graph would look like. Let's try some of the OR inequalities. So the first one is saying that the absolute value of x plus 3 is greater than 8. So we have x plus 3 that is greater than 8, or we have x plus 3 is less than negative 8. Same thing happens when the expression inside is negative. We're multiplying both sides by a negative, which flips the sign. So solve each one by subtracting 3 on both sides. So you have x is greater than 5, or you have x is less than a negative 11. And then we can graph this inequality. Okay, so if x is going to be greater than 5, we'll have an open circle at 5, and it'll point to the right. And if x is less than a negative 11, it'll be an open circle, and it will point to the left. So you might want to write what those numbers are. You know, above them, that's fine. But remember that these are the type. These OR compound inequalities go beyond. So they're the OR inequalities. Let's look at the example number 2. So in this one, we could shape it up a little bit by first adding 3 to both sides to get the absolute value of n plus 2 to be greater than or equal to a negative 3. Now, because it's saying that it is greater than or equal to a negative 3, right? Because remember, by definition, it cannot be less than 0. It's always going to be greater than or equal to all the negative numbers. So this is true for all times, right? It will always be by definition. So the solution is all real numbers. Okay, that's part of your answer. And it's by definition, the absolute value will always be greater than a negative number. Greater than, equal to, and in this case, that negative 3. So when we graph it, we can just put a couple numbers down and then color it in, showing that it is all the numbers on the number line going in both directions. Okay? And then finally, the last one, we want to add 7 to both sides. Get this in a better shape here. So 3 times the absolute value of d plus 1 will be greater than or equal to 6. Divide both sides by 3, which is a positive 3, so that cancels, and then you get the absolute value of d plus 1 being greater than or equal to 2. So you have this OR inequality situation, compound inequality situation going on. You have d plus 1 that is greater than or equal to 2, or d plus 1 is less than equal to negative 2. Again, the expression inside, d plus 1, if that happens to be negative. In order to be able to write it like this, when we don't want that left-hand side to be negative, we're multiplying both sides by a negative number. We have to flip that inequality symbol. Okay, so we'll solve them the same way by subtracting 1. Make it a little less messy there. So we have d will be greater than or equal to 2 minus 1 is 1, or we have d less than or equal to a negative 3. And now we'll graph that compound inequality. Where we have d greater than or equal to a 1, so we'll go ahead and shade that in. And it's a solid circle at 1 going to the right. And if it's less than or equal to negative 3, it's a solid circle at negative 3, and it's going to the left. And finally, the concept summary for solving all of inequalities. We started out this chapter learning about one-step and multi-step inequalities, where we follow the steps for solving an equation, and you reverse the inequality symbol when multiplying or dividing by a negative number. That basic solution solving method is true for even the compound inequalities. In the compound inequalities, if necessary, write it as two separate inequalities, then solve them separately and include and or in the solution before you graph it. Remember that and means numbers between, or means the numbers beyond. The absolute value inequalities, if necessary, isolate the absolute value expression on one side of the inequality, write the absolute value inequality as a compound inequality, and then solve it.